Greetings and welcome, friends. Mr. Wada here. We were talking about like properties of parallelograms. We demonstrated and proved a whole bunch of things yesterday, and these ones, once you know them, they're pretty easy to apply. This is from page 372. It says, find the value of the variable in the parallelogram. Well, let's see. If I want to find the z, I know that opposite sides in a parallelogram are congruent. And then by def of Kong, their measures will be equal. So let's see, add 8 to both sides. It looks like 28 would be my solution. And then as far as these angles, this guy is an angle here. You can tell by that degree. And opposite angles in a parallelogram are congruent. And if those angles are congruent, then their measures are equal by def of Kong. So therefore, d minus 21 equals 105. Add 21 to both sides. D is going to equal 126 degrees. Yeah. All right. Good times. Good times. All right. Here's another one coming at you. Example 2. It says find the measure of the indicated angle in the parallelogram. Let's see. So a measure of angle B. Well, those angles are consecutive angles in a parallelogram. By consecutive in terms of parallelogram, it means like as you would go around the shape, they are two that are side by side as opposed to opposite angles of one another. Those angles are going to be supplementary, and by definition of supplementary, that means that their measures will add to be 180. Subtract 51 from both sides. With the subtraction, can I do it? 129, I'm guessing. Looks like golden. Lovely. All right, let's keep going. I do have a proof at the end of this, so trying to make sure we get to that. Thank you kindly. We'll figure out your seat after. We did swap them around, but just hang out for now. You can find a seat. You can settle in. It's a half day anyway. Let's see. It says find the indicated measure in parallelogram element Q. Explain your reasoning. All right, there were a whole bunch of different questions here. I just thought it'd be interesting. Actually, tell you what, let me just do one of these. Let's just talk about some of these properties in general, and then you could have filled in the blanks as you needed to. All right, so if this is 100 degrees, then that means this is 100 degrees, right? That big angle there. That would also mean that this angle is what? 80 degrees, because it's consecutive to those ones, and these ones would be 80 degrees as well. If this is 29 degrees, well, these are parallel, so I'm guessing like this one by alternate interior would also be 29 degrees. It doesn't seem like that was that helpful. I'm assuming it relates to something. 8.2, I'm assuming relates to this length, and the diagonals in a parallelogram are bisected by one another, so that means this would also be 8.2. If this is 7, then that means this is 7. If this is 8, then that means this over here is 8, because opposite side, parallelogram, opposite side theorem, right? You got all those. If this is 13, then this is 13. We had parallelograms with all their properties. Good stuff, good stuff. Did I hit them all? I think I did. Right? So you could MNQ? MQ. All right, so yeah, double 8.2, and you'll get, yeah, 16.4 for MQ. All right? So, yeah, all sorts of different properties that are at play. Good old parallelograms. I like them. All right, ooh, here we go. Can we prove the parallelogram opposite angles theorem? So they set us up with a bunch of gimmies. It's a parallelogram. Wah, wah, wah. All right. And we want to prove that the opposite angles are congruent. Oh, this one's actually a little bit interesting. I might, instead of using angle addition property, I would probably just draw this two separate ways. But anyways, ABCD is a parallelogram. I can draw a diagonal BD. So the fact that it's a parallelogram, I would have BC is parallel to AD. I could have AB is parallel to CD. Right? Those things are true if I ever knew that. Why are those true? Yeah, def of, man, I actually have to write out parallelo. I'll just write parallelo, because if I just write parallel or para, like you wouldn't know if I'm talking about like something about parallel lines or something. So yeah, so there we go. What's some other facts that might help us out here? Oh yeah, we love that one. I love it. Good call. BD is congruent to BD by reflexive. All right. I'm assuming. All right. Let's actually talk about this real quick. I'm assuming we are going for some type of triangle congruence here, right? If I was outlining this, I mean, it's not a bad idea. Sometimes you can just start like, I'm just gonna write things that are true, and then hope that they compile themselves into something meaningful. Josh, what are you thinking? A and C, I could show that, well, those aren't alternate interior to each other. Angle A would be alternate interior to this one. I could say that this little angle and this little angle are alternate interior, which I'm wondering if that's what the direction that they're thinking of going eventually anyway. All right, let's see. Let's keep going here. I feel like I lowered my desk chair here too much. Here we go. All right. So BD is reflexive. Let's talk some angles here. Actually, yeah, let's talk the angles that we just did. This angle is congruent to that angle. So let's see if we can name those. So CBD is congruent to angle ADB. Right, so those ones are alternate interior angles theorem. I also could similarly, with a different pair of parallel lines and a different pair of angles for the same reason, say that angle ABD, right, this one here. It's not a bad idea to label your sketch as you're making your statements either. CDB. All right. I knew we were going to slow down on this proof, but that's okay. All right, do I have enough information to prove those two blue triangles congruent? I'm even going to write this in blue. I'm going to say triangle ABD is congruent to triangle, who now? ABD. So I start at the far one, so it starts with C. CDB, right, yeah, yep. And why are those triangles congruent with the information that I have? Angle, side, angle. All right. Now that I've proven those triangles congruent, I can say things about their corresponding parts. Perhaps you agree? So I bet I could say something like this. Angle A is congruent to angle C. Angle A is congruent to angle C. By which reason? C, P, C, T, C. Corresponding parts of congruent triangles are congruent. Now, I just proved this piece. I technically could say by like case 2, draw a diagonal A to C, and then you'd be able to prove using exactly the same logic that B is congruent to D. I'm guessing that they would probably have been going for the route of angle addition and saying that, okay, these two congruent angles that add together are going to be congruent to those two angles that are added together. But I'm just going to be like angle B is congruent to angle D by same reasoning. All right. But I do want to point out that there's another way to do it. When drawing AC as a diagonal, or diagonal AC. Right, so I don't think we need to do it again, and I think that's a way easier way to do it than the angle addition stuff. All right, well, thanks for watching, friends. Have a great day. Bye-bye.